Dear viewers, good evening from beautiful city Kota Malaysia, Sabah. So today once again I am discussing regarding the circuit theory, electromagnetic theory, and related energy system interrelationship. Introduce myself again. I am Bablu Kumar Ghosh, senior lecturer in the Faculty of Engineering, University Malaysia, Sabah. So today our discussion point actually at how the correlationship between the circuit theory and electromagnetic theories. So first we discuss about the charge and voltage in the circuit theory or system of electricity that is associated with the electromagnetics, electrostatic or electric field, while the electric current actually associated to the magnetostatic or magnetic fields. At the same time, the time varying voltage or current that is in the electrical circuit or system that is associated to the electrodynamics or electromagnetic systems of the then the relationship of the charge accumulation, that how we associate with the energy accumulation, electrical energy as charge accumulation in the systems, that is truly associated with the voltage or electric field increases in the systems. And finally, it actually electrical energy storage in the system increases. Then the flow of charge, if it increases, that eventually increase the electrical current in the circuit or systems, and it eventually the magnetostatic or magnetic field increases. Then time varying voltage or current once increase, that eventually increase the electromagnetic energy transfer process, and it is actually in some sense of frequency domain electromagnetic system analysis. Then the correlationship between the displacement charge spectral and electric field that is associated with the electric permittivity. So the charge accumulation whenever increase, that eventually increase the electric potential or field, and that eventually increase the electrical energy storage in its systems, and that is equivalent to the system relative permittivity or electric flux density increases. At the same time, whenever the magnetic flux density or magnetic field intensity varying with the permeability of the magnetic materials, that actually support the flow of charge increases or electric current increases in the system, that enhance the magnetic flux or field, and ultimately that will induce the magnetostatic or magnetic field increasing tendencies, that eventually equivalent to the relative permeability or magnetic flux density increases. So think that the systems how it stores to transfer from electrostatic to magnetostatics is varying with the permittivity and permeability aspect. Then the three pillars of experimental electromagnetics theories actually electric charge as we described by the Coulomb's law, and then the current carrying wires as we described by the Ampere's law of force, and the magnetic field that senses time induced electromotive force as we discussed in the Faraday's law. So these three experimental pathways of electromagneto and electromagnetic systems actually very significant for analysis or further in the Maxwell theories. So the Coulomb's vector A, we know that any common vector that multiply with the operator in three ways, that is the three ways an operator can act, that is actually a scalar function of t, say this is a operator del t is actually the determine the gradient. Then on a vector function v via the dot product operator del dot v, actually it is represent a divergence that we find in a gradient of electric field or gradient of temperature that can produce variation of energy or electrical or thermal energies. Then the gradient of the electromagnetic energies that transfer in the system or space or any system, that is actually not this way of this divergence. It is actually the electric and magnetic field this perpendicular to each other, that is the curl forms, and there is no dissociation of energy, and that's operators with the cross product of vector v, that is actually the curve. So if we consider it actually from scalar to vectors, and called actually divergence, and called how interrelated with the electrostatic system and electromagnetic systems that will be discussed later. So electromagnetostatic concept actually the interface of the electrostatic of electric field and the interface of magnetostatic of magnetic field that is related to E and current density J. So then the relationship between the E and J, or electric field and current density, actually the conductivity of any material. So any conductive materials, actually both electrostatic and magnetostatic fields are coexistence, and its intensity depends on the different parameters. So the electric field is completely determined by the stationary charge present in the systems, while magnetic field also completely determined by the current. So they are coupled in a system that is actually follows the Ohm's law, that J equal to sigma E. So J is actually represent the magnetostatic systems if it is the static charge, static current density, and then electric field is E, that is also static. So their interface actually conductivity. That means J is proportional to E, and that is the sigma is the conductivity of the system. So such a situation, it is actually, is it really a electromagnetostatics or what? So it can be separated into two parts actually. The current densities, we can represent it actually two part. One is the static, another is the dynamic part, or conductive current and displacement current. So from this relationship, we know that Ampere's law and the continuity equation, that the curl of magnetic field intensity is actually, that is the conductive current density, and the displacement charge variation with the time. So that is actually displacement current density. So the association of curl of magnetic field intensity is actually determine the conductive current density and the displacement current density. But how extent it vary from conductive to displacement, it depends on the conductivity and frequency and permeability of the materials. Similarly, the static is the curl of its magnetic field intensity is nothing but it's simply the current density. So the Faraday's law, that energy transfer phenomena, we know that induced potential, that we induced any system, that either it is the mutual induction process or a transfer process around the loads, short way distance, long distance, that we see in the electromagnetic system, that the gradient of magnetic flux densities with over this integration of surface area of Rayleigh's, it is determined the mutual EMFs and the curve and the charge dip velocity with the cross product of magnetic flux densities. Actually, its overall position domain, the integrations determine the dynamic EMFs. So both the mutual EMFs and dynamic EMFs, um, uh, it actually varying with the system with some extent, because normally this first term is related to the power or frequency, that is a transformer energy transfer is the position domain, that from one position to another position. But for the long distance, we determine the electric current dynamic phase, that with the time varying magnetic field, that determine the long distance electromagnetic transformation. So the Maxwell equation in force in space, actually you can determine these are the, from the Gauss's law, both differential and integral form, then Gauss's law for magnetism, both differential and integration form, then Faraday's law of induction, and finally the Ampere's critical law with the Maxwell correction, that also depends on this permeability and permittivities of the systems. Then for free space, we know that the speed of light is very high, that is depending truly on the absolute permittivity and permeability, while as any medium that has higher relative permittivity and permeability, definitely their interaction of this medium compared to the free space, energy will be lost, and that's why the speed of the electromagnetic signal will be reduced. So the electromagnetic circuit theory and its optical system, if we consider from the Maxwell equation, we first discuss about the electrostatics and magnetostatics as a static phenomena, followed by the electromagnetic waves as a electrodynamic phenomena, and then electromagnetic waves is also classified in the circuit theory as a transmission line theory, Kirchhoff's law, and that is actually comes from different pathways from circuit theories. And then finally the geometric optics that deals with the part of the Maxwell theory that is actually very much significant now in optics and optical systems in different technological innovation and advancement of communication and this energy interface. So that is basically the optical energy transfer process. Then several optoelectronic system and devices actually interrelated with this system. So this is the overall picture of Maxwell equations with the electrostatic, magnetostatics, electrodynamics, and geometric optics, and it associated theory with the circuit and systems, and also energy transfer phenomena in the optoelectronic systems. So the materials overview, if we consider the electrical energy source has high specific resistance and permittivity, while greater permeability materials induce magnetic field that allow to transfer electrical energy, as we know that transformer phenomena or mutual inductance phenomena. Then higher conductive materials, neither higher permittivity nor higher permeability. So what is that? That is actually higher conductivity domain, there's conduction, but it is frequency domain. Higher frequency, it might be no more conductors. It can radiate the energy from the surface. That is depends on the skin depth. In electrical system, the dielectrics has higher permittivity, while magnetic system core material has higher permeability. So diverse level of both are needed for electrical and electromagnetic energy systems. Then the electrical and optoelectrical energy transfer materials relation, if we discuss finally, then the materials occupied higher relative permittivity and permeability is determined higher electrostatic and magnetostatic properties. Then low frequency circuit allows conductive current, while high frequency displacement current is predominant at the high frequency systems or circuits. As per Coulomb's law, the materials with higher relative permittivity has lower binding energy, so their energy transfer or process is easier, while the diverse type of dielectrics of diverse permittivity utilize for multipurpose energy storage and transfer systems. And close proximity, the energy transfer purpose, higher permeability interface, while long distance energy transfer purpose, less loss dielectric or magnetic interface is required to lessen the system loss. That's all from my side. Thank you.